Hello, welcome to Analytic Geometry for Chapter 10, and we are talking about slopes of parallel lines. So if you remember when we talked about slope in algebra, we talked about slope equals rise over run. Well, that's actually a ratio of the vertical change over the horizontal change. We also talked about that back in Chapter 4. So I just also want to mention here that slope measures the angle that a line makes with the horizontal axis. So if you look here, if you have two parallel lines, the horizontal axis is a transversal. So angles 1 and 2 that are marked here are corresponding angles. And that is exactly how you would prove that these lines are parallel. The proof is just a short 5-step proof. It's on page 432 if you want to take a look at that. But what if we have an equation of a line and we have a point of the other line? So say we know the equation of line 1, but we only have a point on line 2, and we need to find that equation. If you remember from Algebra 1, they have the same slope. So if we can get the slope of line 1, we can use point slope form. So let's go ahead and try. So the first step is, here we have a point on a line, and the other line is given to us. But we need to have this in slope-intercept form, which you guys normally call it y equals mx plus b. We need to have it in that form so we know the slope. So the first thing I'm going to do is subtract 3x from both sides. Then I'm going to divide everything by 4. So I know now my slope of the first line is -3/4. Now I'm going to use point slope form to find the other line that I don't know. So I have the slope, and I'm going to plug that into my point slope form, and then the point that I have. So remember, the y is -1 and the x is -2. My slope is -3/4. So now I'll simplify and then go ahead and put that into slope-intercept form. And that's the equation of my new line. So these lines are parallel because they have the same slope and they have different y-intercepts. Let's do one more just to be on the safe side. So first step is to find the slope of my original line. Okay, so I subtracted 2x from both sides, and then I had to divide everything by -1. Now I know my slope is 2. So now I'm going to plug that into point slope form and plug in the point as well. So I've substituted in my slope, my y, and my x of the point given. Now I'm going to simplify, and now I'm just going to solve for y. So all I have to do is subtract 2 from both sides, and that's the equation of my new line. Now remember, with analytic geometry sections, we don't have a whisk summary that you need to submit to me, but you do need to go ahead and do the exercises. Now I'm going to let you skip number 4 because that's a proof. It says prove that parallel lines have the same slope. I'll give you extra credit if you want to go ahead and try it. And then, but I want you to do 1, 2, and 3. And then number 5, it says combine the two theorems about parallel lines and slopes by writing a biconditional statement. So I want you to try to make a biconditional statement, and which, remember, that's an if and only if statement that combines both theorems. So I do want you to go ahead and try that one. So we will go over these in class, and I will see you then.